Okay, Chapter 3.7 Antiderivatives. Question 14 says a car traveling at 46 feet per second decelerates at a constant 5 feet per second squared. How many feet does the car travel before coming to a complete stop? What we are given is the velocity at time 0 is 46, so v sub 0 is equal to 46. We are also given 5 feet per second squared, which is our acceleration, and it's a negative 5 because it's decelerating. So we know that a of t is equal to negative 5. The question's asking us to find how many feet does the car travel before coming to a complete stop. And so we have to recall that the antiderivative of the acceleration with respect to t is the velocity plus some arbitrary constant. So, well, we have our a of t, so I just have to integrate negative 5 dt, and you would get negative 5t plus c. And this is all equal to v sub t. Well, now we need to find this c value. But we know when we plug in 0 to the velocity function, we get 46. So what that means is v sub 0, or v of 0, is equal to negative 5 times 0 plus c. And we know that v of 0 is equal to 46 from above. So 46 is equal to c. So what that implies is that the velocity function is equal to negative 5t plus 46. Well, that helps because we need to find when we're asking for how many feet does the car travel, we're looking for the position function, s of t. And we also know the velocity at time t will also be 0. So we need to find t before we plug it into the position function. And we actually need to find the position function as well. But let's find t from the velocity function. So we know the velocity at time t and time 0. Well, the velocity at time t would be 0. So we have 0 equals negative 5t plus 46. And we solve for t, and we would get t is equal to 46 over 5. And now, to find the position function, we have to recall that the antiderivative of the velocity function is the position function. Okay, so let's integrate our velocity function right here. So the integral of negative 5t plus 46 dt. And when we take the antiderivative, this becomes a t squared. And now I have to divide by that power right here. So this would become a negative 5 halves. So we have negative 5 half t squared. And a constant just adds on a variable of t. So this would be plus 46t. And we have another arbitrary constant. And this is our position function. Well, the position at time 0 would be 0. So we know s of 0 is equal to 0. So we can find C by plugging this in, and what we would get was C equals 0. So our position function would just be the negative 5/2 t squared plus 46t. Well, we need to find how many feet does the car travel before coming to a complete stop. Well, we have the time when it comes to a complete stop, and we have the position function. So now we just have to plug in the time into the position function. So S of 46 over 5 is equal to negative 5 divided by 2 times the quantity 46 over 5 squared plus 46 times the quantity 46 over 5. And you can do a little simplification. So I know that this becomes 46 squared over 5 squared. But a 5 divided by a 5 squared, you just left with 1 5 on the bottom. So I would have a negative 46 squared left on the top divided by 5 times 2. And then add that to 46 squared over 5. Well, now I need a common denominator. I see this has a 5 and a 2, and this only has a 5. So I have to find a number that I can multiply into this fraction to get the bottom equal to 5 times 2. Well, if we multiply both sides by 2, we would get negative 46 squared over 10 plus 2 times 46 squared over 10. Well, if you have negative 1 of something and then you add 2 of that, you're just left with 1 of that thing. So we're just left with a 46 squared over 10. For a little more simplification, we could also distribute, well, not distribute, we can rewrite this as 40 plus 6 squared, or 40 plus 6 times 40 plus 6. And what you would get would be 1600 plus 480 plus 36. And so that would be 6112 all over 10, or about 211.6 feet. So this is our final answer. The car will travel 211.6 feet before coming to a complete stop.